draw a circle through three non-collinear points. Suppose you have three non-collinear points. I'll take three non-collinear points as A, B and C. Okay, non-collinear points means that points which are not on the same line. If three or more points are on the same line, then we say that points are collinear points. If three or more points that are not lying on the same line, that are called non-collinear points. Okay, so we taken here three such points, means these 3 points they are not lying on the same line. So then how to draw a circle passing through these 3 non-collinear points? To draw that, first you have to join AB and AC. Okay, any 2 lines you have to draw like this. Either you can join AB and AC, or you can join AB and BC. 2 lines you have to get like this, either AB and AC or AB and BC. After that, take your compass. In a compass, what you have to take is you have to take a AB length. Okay, you know how to draw perpendicular bisector of a line. To draw a perpendicular bisector of a line, you have to take that length, that line length in your compass, and keep it one tip of that line, and draw one arc above the line and below the line. Now above the line AB and below the line AB by keeping it A, and next you have to do same type by keeping at another end of that line. Okay, draw one arc above the line and below the line, now AB. Okay, so now you will get 2 points of intersection of arcs. Okay, that 2 points of intersection you have to join by using your scale. Okay, like this you have to join, and this is what this is the perpendicular bisector of AB. Same type you have to draw perpendicular bisector of another line AC also. Okay, suppose you joined AB and BC, then you have to draw perpendicular bisector of BC. Now we joined A and C, so you have to draw perpendicular bisector of AC. For that you have to take AC length in your compass like this. Okay, and draw one arc above AC and below AC by keeping at one end. At A I kept, next time you have to keep it another end of that same line and draw one arc above the line and below the line. Again you will get 2 points of intersection of arcs which is drawn above and below. Okay, that 2 points of intersection you have to join using your scale. Okay, so now you see where we drawn perpendicular bisector. See, one is this one, this line. This is the perpendicular bisector of AB, and this one is the perpendicular bisector of AC line. That 2 perpendicular bisectors meeting at which point? That point will be the center for our circle. That is the circle passing through these 3 points. Okay, so if that is the center, then what will be the radius? To get a radius, you have to keep a compass tip at that center and keep another tip of compass at A or B or C. Okay, that will be the radius for your circle. So now I taken OA length. Okay, one tip at O, another tip of compass at A. Your sharp tip of compass must be at center O. Okay, and another tip must be at A or B or C, any. Okay, now you draw a circle. That circle will pass through all these 3 non-collinear points. You can see. Okay, if you drawn exactly what I explained like that, then you will get a circle which is passing through that 3 non-collinear points. Okay, thank you. Next, suppose you are given a arc of the circle. Arc means a part of the circle. Then how to complete a circle? To draw a circle, we need a center of that circle, center and a radius of the circle, right? So how to get a center of the circle? For that you have to use a same procedure what we done in that is a circle passing through 3 non-collinear points. What we done in that same thing we have to do here also. Okay, so suppose you are given an arc of the circle like this, you have to take 3 points, any 3 points you can take. Okay, I'll take that 3 points on this arc as a AB and C. Okay, now you can see these ABC points are non-collinear points. Now you know how to draw a circle passing through these three non-collinear points. Okay, for that what you have to do, you have to join A, B and AC. Okay, or you can join AB and BC. Okay, I taken here AB and AC. After that you have to draw perpendicular bisector of both the lines AB and AC. Now first perpendicular bisector of AB. To draw that, take AB length in your compass and draw one arc above AB and below AB, and repeat the same procedure by keeping it another end B. Okay, above one arc and below one more arc, and that two arcs will meet at one point, meet at 2 points. Here these two arcs will meet at this one point, and these two arcs will meet at this point. So you will get two points of intersection of these arcs. Join that points of intersection. Okay, like this. And one more line is there, AC line. For that also you have to draw perpendicular bisector. For that you have to take AC length. Okay, take AC length like this, and next what you have to do is you have to draw one arc above AC and below AC, and repeat same type by keeping it another end. Okay, draw one arc above and below AC. Now also you are getting 2 points of intersection, and that 2 points of intersection you have to join by using your scale. Okay, like this. And here they are meeting, some perpendicular bisectors are meeting. Suppose they are not meeting, what you have to do is you have to extend that perpendicular bisectors. Okay, below you have to extend. So then they will intersect at one point. That will be the center for your circle. Okay, and now what you have to do is you have to keep a sharp tip of your compass at O, and another tip of compass at A, or you can keep it B, or you can keep it C. Now your compass with the length radius of this circle. Okay, so next what you have to do is you have to complete the circle. Okay, you have to complete a circle like this. Okay, if your compass is proper, scale is proper, and pencil tip is sharper, then you will get exactly the circle which is passing through these three non-collinear points and containing this arc. Okay, thank you. Suppose you are given a circle like this, then give a construction to find the center of that circle. You are given a circle, but the center of that is not given. So then how to find its center? For that what you have to do is you just mark any 3 points on this circle, so that they are visible. They are visible means when you join AB and AC, you can see that lines AB and AC. Like that you have to take 3 non-collinear 3 points on that circle. Don't take points like this A, B, C. Okay, if you take like this then you can't see AB and AB and AC, BC lines. So for that reason you take 3 points A, B and C on this circle, so that you can draw perpendicular bisectors of AB and AC without any doubt. Okay, so after marking 3 non-collinear points, you have to join AB and AC, or AB and BC. Okay, what we done in that case, that is we drawn a circle passing through 3 non-collinear points. Same thing you have to do here also. Okay, but here non-collinear points you are not given, but you can take 3 non-collinear points, but that 3 non-collinear points must be on this circle. Okay, so like that I taken 3 points A, B and C. After that I joined A and B and A and C. Now you have to draw perpendicular bisectors of AB and AC. Okay, take AB length and draw one arc above AB, below AB. Next repeat the same type by keeping it B, above and below AB you have to draw arc. Okay, and that arcs will meet at 2 points. That 2 points you have to join using your scale. Okay, and repeat a same procedure for AC also. That is, you have to take a AC length now in your compass and draw one arc above AC and below AC. Next, repeat same type by keeping it C below AC and above AC. Okay, that arcs will meet at 2 points. That 2 points you have to join. Okay. So now that are two perpendicular bisectors, perpendicular bisector of AB and perpendicular bisector of AC, that will meet at one point and that point will be the center for your circle. Okay, you are given a circle but center of that is not given. So we got now center of the circle. How we got? We taken 3 points on that circle. And next we joined AB and AC. After that we drawn perpendicular bisector of AB and perpendicular bisector of AC. I will name that as a PQ and RS. Okay, what is a PQ? PQ is the perpendicular bisector of AB and RS is the perpendicular bisector of AC. Now that two perpendicular bisectors will meet at one point. That point will be the center for the given circle. And you have one theorem that there is only one circle passing through 3 non-collinear points. Okay, so there is only one circle passing through 3 non-collinear points. Why? Because you can see the perpendicular bisectors of AB and AC that will meet at only one point. So that will be the center for the circle. So you can draw only one circle passing through 3 non-collinear points. Okay, actually that is the next theorem. Theorem 5 that says like this, there is only one circle which is passing through the given 3 non-collinear points. Why? Because you can see here perpendicular bisectors of AB and AC that will meet at only one point and that will be the center for our circle, and you can draw only one circle using that as a center, O as the center and OA as a OA or OB or OC as a radius. Okay, so there is only one circle passing through 3 given non-collinear points. Okay, thank you. Next, draw different pairs of circles. Means 2 circles you have to draw. How many points does each pair have in common? What is the maximum number of points? What is the maximum number of common points for that pair of circles that you have to find? Okay, so you have in this 3 cases, case 1, case 2 and case 3. Case 1, in that there are no points in common. Suppose you draw 2 circles either in this way or in this way, then you can see there are no points in common for these 2 circles. Okay, common point means that point should belongs to this circle as well as for this circle, and you can see here there are no common points for these 2 circles, and here also there are no points in common for these 2 circles. Okay, so that is the first case, and case 2 is that only one point in common. Suppose you draw circle in this way, then that 2 circles have only one point in common. Okay, point P belongs to left circle as well as right circle also. Okay, and here if you draw 2 circles in this way, then also you have only one point Q in common. Q belongs to inside small circle, also it belongs to outside bigger circle. Okay, so only one point you can see here common for these 2 circles. So this is the second case, only one point in common. And third case is that if you draw 2 circles in this way, then you can see only 2 points are common to these 2 circles. Okay, point P belongs to left circle as well as right circle, and point Q that also belongs to left as well as for a right circle. Okay, so there are 2 points in common, and you cannot draw 2 circles so that you have more than 2 points in common. You can draw 2 circles having a maximum number of common points only 2. Okay, so the answer for this question is that that is for the last question, what is the maximum number of points in common? Okay, for that what is the answer? By observing these 3 cases, maximum number of points in common is 2 for a given pair of 2 circles. Okay. Next, theorem 6 that says like this, equal chords of a circle are equidistant from the center. Okay, in that you have another sentence also, equal chords of congruent circles are equidistant from their centers. Okay, so in that you have to suppose you take one circle and if you take two equal chords in that, then they are equidistant from the center of the circle. Okay, so here I drawn one circle and if I take two equal chords, I will take two chords of length 15 centimeter. Okay, 15 centimeter. For example, not exact this one, and here also I will take one more chord of length, same length, that is how much AB measures same length this chord also CD. Suppose you take for example 15 centimeter chord, then they are equidistant from the center of the circle. How to get the distance of the chord from the center of the circle? What you have to do is you have to draw perpendicular from the center to that chords. Okay, from O I will draw perpendicular to AB chord. I will name that as a OM. What is OM? OM is the perpendicular drawn from the center to the chord AB. Okay, and OM, length of OM, that gives you the distance of the chord AB from the center. And same type you draw perpendicular from the center O to the chord CD, and we take that as a ON. Okay, so ON is what? ON is the perpendicular drawn from the center to the chord CD, and length of ON, that gives you the distance of the chord CD from the center O. Okay, and suppose for example OM measures 5 units, then ON also measures 5 units. Okay, we can do one activity, just draw one circle and take two equal chords like this, AB and CD, two equal chords, and you draw perpendicular from the center to both the chords AB as well as CD, and you measure these two perpendiculars. Okay, they will measure same. Okay, they will measure same. So that shows that the chords of a circle, equal chords of a circle are equidistant from the center. Okay, always equal chords are equidistant from the center of that circle. And if you take two congruent circles like this, congruent circles means what? Congruent circles means circles with the same radii, or circles of a same size. Okay, they have same radii. Suppose you take two equal chords like this, suppose 10 centimeter chord you take in these two circles, and if I take center of this circle as P and center of another circle as Q, then these two chords, if I name that as AB and CD, then these two chords are equidistant from their centers. Okay, so if I draw PM perpendicular to AB and QN perpendicular to CD, then both the PM as well as QN, they are equal. They are equal means what? That implies, you know that this perpendicular, that gives you perpendicular length, that gives you the distance of the chord AB from the center P, and length of QN, that gives you the distance of the chord CD from the center. Okay, so if PM is equal to QN, that implies what? That implies equal chords AB and CD of these two congruent circles are equidistant from their centers P and Q. Okay, so that is about theorem theorem 6. So in that what we taken, if chords, two chords AB and CD are equal, then what we can say, then they are equidistant from their centers, means OM is equal to ON for that figure. Okay, for this figure. And next you have theorem 7 that says, that is actually the converse part of theorem 6. What it says, if chords are equidistant from the center of the circle are equal in then they are equal in length. Okay, if chords are equidistant from the center of the circle, then they are equal in length. Okay. So to understand that, I'll take one figure. You also do one activity that you just draw one circle and you take two chords in that circle such that they are equidistant from the center. Okay. And here I will take one chord that is at a distance 5 units 5 centimeter from the center of the circle. Okay. I will take that chord as AB. I will take one more chord which is at a same distance 5 centimeter distance from the center of the circle, and I will take that as a CD. So what we taken here, we taken two chords AB and CD. They are equidistant from the center of the circle. Okay, both are at 5 centimeter distance from the center of the circle. So then what we can say about AB and CD, they are equal. Okay, they are equal in the length. You can do one activity, just draw one circle and take two chords in that circle such that they are equidistant from the center, like this. If you take one chord at a 5 centimeter distance from the center, then you have to take another chord at a 5 centimeter distance from the center of the circle. So then you just measure AB length and CD length, they are equal. Okay. So this is about theorem 7. So here what we taken, if OM is equal to ON, OM is equal to ON means what? These chords are equidistant from the center of the circle. So then now what we can decide, then we can decide these two chords are equal in the length. Okay. So that is the theorem number 7. Thank you. Next one is two circles of a radii 5 centimeter and 3 centimeter intersect at 2 points and the distance between their centers is 4 centimeter. Then find the length of the common chord. Okay, I'll draw one rough figure. Exact figure we do later. Okay, you have to draw two circles. One circle is of a radius 5 centimeter, another circle is of a radius 3 centimeter. Okay, and they will intersect at 2 points. So here you can see they are intersecting at 2 points. If you join that points of intersection, then you will get a chord AB that belongs to both circle, right circle as well as a left circle. So that is called a common chord. You have to measure the length of the common chord. You have to find the length of the common chord. So for that what you are given, distance between their centers, distance between, suppose center of this circle as P and center of this circle we take that as a Q. Then distance between their centers is how much? 4 centimeter is given to you. So if you keep this rough figure in your mind, then it is easy to construct. Okay. So now we start with this line, that is the distance between their centers, that is how much? That is 4 centimeter. So you have to draw first one line of length 4 centimeter. 1, 2, 3, 4. Okay, 4 centimeter line, and you take that as a PQ. Okay. Take that as a PQ. What is PQ? PQ is a line of length 4 centimeter. Why we taken 4 centimeter? Because we are given distance between the centers of two circles given to us is 4 centimeter. Okay, and at one end of this line you have to draw one circle of a radius 5 centimeter now. Okay, first you draw one circle of a radius 5 centimeter at one end point P. Next at another end point of that line you draw a circle of a radius 3 centimeter, taking Q as a center. Okay, here you have to take P as a center for this circle. This circle means a circle of a radius 5 units. Now you have to take a 5 centimeter in your compass. Okay, take a 5 centimeter in your compass. 1, 2, 3. You have to take a 5 centimeter length in your compass. One tip must be at a 0 of your scale and another tip of compass must be at a 5, okay, in your scale. So then now your compass will be with the length how much? 5 centimeter, and you draw one circle by taking P as a center and radius we taken here 5 centimeter, okay. Complete a circle. Draw circle of radius 5 units with the P as a center. Now at another end point, taking that another end point as a center of the circle, you have to draw one circle of a radius now 3 centimeter. For that you have to take a 3 centimeter in your compass, okay. One tip must be at a 0 of your scale, another tip of your compass must be at a 3, okay, 1, 2, 3. So like this you have to take a 3 centimeter in your compass, and after that keep a sharp tip of your compass at Q, that is we are taking Q as a center, and now your compass with the length of 3 centimeter means we are drawing a circle of radius 3 units, okay, 3 centimeter. So now complete a circle, okay, like this. So now you can see these two circles, they are intersecting at 2 points. We name that 2 points as A and B. I'll take this point of intersection as A and this point of intersection of these two circles as B. Now you join A and B. What is A and B? That is the common chord. Now just measure the length of this chord, okay, 1, 2, 3, 4, 5, 6, and this measures 6 centimeter. So in the side of a figure or below the figure you have to write a common chord, common chord is what? Common chord we named that as AB, and the length of that we measured in the figure, that measures how much? That measures 6 centimeter, okay. Thank you. Next problem is if equal chords of a circle intersect within the circle, equal chords of a circle intersect within the circle, then you have to prove that the line joining the point of intersection to the center that makes equal angles with the chords, okay. I'll draw a rough figure. Suppose you draw one circle, and if you take two equal chords, AB and CD, we can see these two equal chords, they are intersect within the circle, and I'll take that point of intersection of these two equal chords as E, and suppose the O is the center of the circle, then you have to prove that the line joining what and what? Line joining the point of intersection, that is E, to the center, that makes what? That makes equal angles with the chords. Here you can see this is the angle made by this line segment with the chord AB, and I'll take that as angle 1 and angle 2, that is what? That is the angle made by this line segment with the chord CD. You have to prove these two angles are equal. Angle 1 is equal to angle 2. We draw exact figure, okay. So what you have to do is first you have to draw one circle, and next you have to take two equal chords such that they are intersect within the circle, okay. So here I'll take the center of the circle as O, and now you have to take two equal chords such that they are intersect within the circle. I'll take this chord as a CD, and one more chord I'll take of a same length, okay, same length, and that will intersect with this chord, and I'll take that chord as AB, okay. This is AB. How AB and CD are? They are equal chords. AB and CD are equal chords, and they are intersecting within the circle, and we take that intersection point of these two equal chords as E, And next you join O and E. What is that? OE. OE is the line segment that is joining the point of intersection E with the center of the circle. You have to prove that line makes equal angles with the chords AB and CD, that is angle 1 is equal to angle 2, that you have to prove. Okay, for that you have to draw one more thing extra, that is you have to draw perpendiculars from the center O to these two chords. Okay, I'll take OM, that is the perpendicular drawn from the center to the chord AB, and I'll take a perpendicular ON, that is drawn from the center O to the chord CD. Okay, and what you know about OM and ON, since we taken two equal chords AB and CD, what theorem 6 says that equal chords of a circle, they are equidistant from the center of the circle, that you know. So by that can I say OM is equal to ON. What is OM? OM is the distance of the chord AB from the center O, and ON is the distance of the chord CD from the center O. So we know that by theorem number 6 that OM is equal to ON, and you can see here one side that is common to both triangles, that is that is OE. OE side that belongs to left side triangle as well as right side triangle. And what these are OM and ON, they are perpendiculars, means that produce 90 degree on both side of it. So what you have here, triangle OME and ONE, both are right angled triangles. Okay, so you have to consider that two triangles, OME triangle and triangle ONE. In that two right angled triangles, OM is equal to ON. Okay, detailed steps we already given in your notes. You have to write that, not this one. This is only for a revision. Okay, you have to take these two triangles, OME triangle and ONE triangle. In that triangle, I already said OM is equal to ON. Why? Because we know that chords, equal chords AB and CD, they are equidistant from the center of that circle. So OM is equal to ON. That reason you have to write here. Okay, by theorem number 6, OM is equal to ON. Why? Because equal chords AB and CD, they are equidistant from the center. So OM is equal to ON. And in the figure you can observe that OE is equal to OE. That is what? That is the common side. Okay, belongs to both the triangles. That reason you have to write here common side. And since this is a right angled triangle, both the OME and ONE both are right angled triangles, by which congruence rule we can say these two triangles are congruent. Triangle OME is congruent to triangle ONE. We can say that is by RHS rule. Why? Because according to RHS rule, it is enough to say two right angle triangles are congruent. You have to show their hypotenuse are equal, and other than hypotenuse, one pair of sides must be equal. Okay, here you have hypotenuse. OE is what? It is a hypotenuse, 90 degree opposite side, both for both the right angled triangles. OE is the hypotenuse. So OE is equal to OE, hypotenuse we equated, and other than hypotenuse, one pair of sides we equated here. Okay, so by RHS congruence rule you can say OME triangle is congruent to triangle ONE. Okay, once the triangles are congruent, then you can equate the angles opposite to equal sides. Now you observe OM and ON. These are equal sides that we know. Now you have to observe the angles opposite to that equal sides. If you shrink OM side, here you will get angle 1. So angle 1 is equal to angle 2. We can say angle 2 is opposite to ON. Okay, if you shrink ON in this triangle, you will get angle 2. So angle 1 is equal to angle 2. What that are angle 1 and angle 2 are the angles made by the line OE with the chord AB and CD respectively. Okay, so that we proved. we are given to prove that the line joining the point of intersection with the center, that is this one OE. Okay, that is the line joining E with the O. Okay, E is what? That is the point of intersection of these two equal chords, and O is the center. Okay, this is the line segment joining the point of intersection with the center, and we proved here that makes equal angles 1 and 2 with the chords AB and CD. Okay, so this is about this problem. Thank you. Next problem is that if two equal chords of a circle intersect within the circle, then prove that the segments of one chord are equal to the corresponding segments of another chord. So you have to take two equal chords in the circle such that they are intersecting within the circle. Okay, I'll take two equal chords AB and CD, and they are intersecting within the circle at a point E, and we take the center of the circle as a O. What we have to prove? We have to prove that the segments of one chord are equal to the corresponding segments of another chord CD. Okay, segments means here parts of the chords AB and CD. Parts of chord AB are what? AE and EB are the parts, segments of this chord, and segments of the chord CD are CE and DE. You have to prove that the segments of one chord, that is AE and EB, are equal to the corresponding segments of the another chord, that is CE and DE respectively. That is, you have to prove upper segments are AE and CE, they are equal, and you have to prove lower segments are DE and EB are equal. Okay, so for that you have to draw some extra figures here. What you have to draw is you have to join OE. Okay, join O and E. Next you have to draw perpendiculars from the center to the chords AB and CD. I'll take OM perpendicular from the center to the chord AB, and perpendicular ON from the center O to the chord CD. And now you can see two triangles that are OME and triangle ONE. That two triangles are right angled triangles. Okay, in that triangles OM is equal to ON. Why? Because you know that chords equal chords of a circle, they are equidistant from the center of the circle. So by theorem number 6 you can say that OM is equal to ON. Okay, that are the distances of the chord AB and CD from the center. So OM is equal to ON. Why? Because chords are equal in length. Okay, and next you can see OE, that is the common hypotenuse for both the triangles. Okay, OE is the hypotenuse for left triangle as well as for a right side triangle. So OE is equal to OE, that is the common hypotenuse. That reasons you have to write. So in these two right angled triangles we equated a hypotenuse, and other than hypotenuse one pair of sides. So what we can say, these two triangles are congruent, we can say. Okay, it is by RHS congruence rule. Once triangles are congruent, then the left pair of sides are also equal. So by that what we can say, ME is equal to NE. Can I say ME is equal to EN? Already these two sides are equal, and OE is equal to OE. So which is the left pair of sides in that two triangles? ME is equal to NE. Okay, ME is equal to EN, or ME is equal to NE. Okay, with this we prove that the segments of one chord are equal to the corresponding segments of another chord. So now I'll take AE. Okay, what is AE? How you can see AE? In AE I'll draw here. This is the chord AB, and middle of that you have M like this, and here you have point E. How AE is? AE, in that you have two line segments AM and ME. Sum of that two, AM and ME, sum of that is AE, right? So AE is equal to AM plus ME, and what is AM? Can I say AM is equal to NC? See, you know that in a circle, if you have two equal chords, for example, if AB is 10 centimeter and CD is of length 10 centimeter, then they are equidistant from the center of the circle, that you know. And in addition to that, we have one more theorem that if you draw a perpendicular OM and ON to AB and CD respectively, then they bisect the chord. Okay, perpendicular drawn from the center to the chord bisect the chord. So by that what we can say, this AM and MB both are equal. Okay, bisect means divides into two equal parts. So AM is equal to MB means both AM and MB both measures 5 units. And same type here also. ON is what? That is a perpendicular drawn from the center to the chord CD. So that will bisect means divides chord CD into two equal parts. So CN is equal to ND we can say. Okay, so you have to keep in mind that AM is equal to MB and CN is equal to ND. And now since AB and CD they are equal, we can say all these parts AM, MB, CN, ND all are equal. Okay, so that you have to write, that you have to keep ready first. What AM is equal to MB and that is equal to CN is equal to ND. This is why, because we taken two equal chords AB and CD, and we know that the perpendicular drawn from the center to the chord bisect the chord. So by that we are getting AM is equal to MB and NC is equal to TN. But since the chords are equal in length, we can write like this, all that parts AM, MB, CN and ND all are equal. Okay, so now I'll take AM is equal to CN. Can I take like that? See here, AM is there, AM is equal to CN we can take. Okay, AM is equal to CN. Why? Because all these are equal. So in place of AM, now I'll write CN and plus what is ME? ME is EN. Now you have to observe the figure. First step we wrote by observing the figure. AE, that is the sum of two line segments EM and ME. After that, using this we replaced AM by CN. You have to look at the figure, then you can understand for AM which one we have to equate. Okay, for AM which one we can equate CN. Okay, so AM is replaced by CN plus ME. For ME, what we have here, ME is equal to EN. Now you have to see CN. CN is this line segment, CN plus EN. EN means this line segment. If you join that two line segments together, which one you will get? You will get CE, right? So AE is equal to, we started with AE and that is equal to CE we proved, means upper segments. AE is equal to CE, upper segments of these two chords are equal we proved. In the same type you have to prove corresponding lower segments are equal. So for that I'll take DE now. Okay, so how we can write DE in terms of this DN? See, you have a chord CD like this. This is a chord CD and the middle of that you have N and here you have point E. How you can write DE in terms of DN? You forget about upper part NC. Okay, just to see now this much. To get the DE, what you have to delete? You have to delete this much portion from this line segment, right? If you delete this portion EN from DN, if you delete EN, you will get DE. Okay, so that is by observing the figure we are writing this step. DE is equal to DN minus EN. Okay, if you delete the EN portion from DN, you will get a DE. So like this you have to start. Okay, now what is the DN? See, DN is this much. DN is equal to MB. Can we say DN is equal to DN? That is here as ND. DN is equal to MB. We can say because here we have all these are equal. So by that we take only these two. Which one we require, only that you have to take. Okay, dn is equal to mb. So I'll replace this dn, that is here as a nd. Okay, I'll replace that by mb and minus what is en. En is equal to me. Okay, so en place we replace a me. Now you have to observe once again that figure. What is mb? Where is mb? I'll draw this inside. Okay, mb is like this, mb, and here you have point E. From mb minus me means from mb you have to delete a me portion, erase this portion. So then what left? eb or be. Okay, so then we are getting be, that is by observing the figure. We started with the de and that is equal to be we proved. So what we proved here, upper segments are equal. What these are? DE and BE, they are lower segments of these two chords AB and CD. So we proved here the segments of one chord, AB are equal to the corresponding segments of another chord CE. Okay, AE and AE and this one BE, they are the segments of the chord AB that are equal to the corresponding segments CE and DE of the another chord CD that we proved. Okay, thank you. Next is angle subtended by an arc at the center of the circle. Okay, so what do you mean by angle subtended by an arc at the center of the circle? Suppose you have a circle like this, and if you have minor arc AB, this side you have minor arc AB and upper side you have a major arc of the circle. Okay, and if you join the end points of these arcs with the center of the circle like this, what are the end points of that arc? Major arc, minor arc, major arc. Both arcs end points are A and B. If you join these end points with the center of the circle, then you have two angles at the center. Okay, this angle I'll take that as angle Y, and this angle, that angle I'll take as angle X. And this angle X, that is called the angle subtended by the minor arc at the center of the circle, and this is the reflex angle, right? Reflex angle AOB. For both the angle X and Y, name is same AOB, but this side you have acute angle, and upper side major arc side you have reflex angle AOB. Okay, just angle AOB, that is angle X, that is what? That is the angle made by or angle subtended by the minor arc. Okay, minor arc AB, and this side angle Y, that is the reflex angle, that is the reflex angle AOB, reflex angle AOB, that is angle Y, and that is what? That is the angle subtended by the major arc AB. Okay, so angle near a major arc side, here major arc you have, angle to the side of a major arc, that is called the angle made by the major arc at the center of the circle, and angle X, that is to the side of a minor arc. Okay, so that is called the angle made by the minor arc at the center of the circle. So you have to be careful. Okay, minor arc side, which angle is there, that is the angle made by this minor arc at the center of the circle, and major arc side, which angle is there, that is the angle made by the major arc at the center of the circle. Next you have important theorem. Important theorem means that statement is important. We are using that to find some angles in circles problems. Okay, and that theorem says like this: the angle subtended by an arc at the center of the circle is at the center is what? Is double the angle subtended by it, means by an arc at any point on the remaining part of the circle. Okay. So, to explain this statement, I'll take one circle and I'll take a minor arc, and next for major arc I'll explain. Okay. Suppose you have a circle with the center O like this, and if this is a minor arc AB, this is the what? This is the minor arc AB. To get the angle subtended by this minor arc, what you have to do at the center of the circle, you have to join the end points of this minor arc with the center. Okay. So, this is the angle x, and what is that angle x? That is the angle subtended by now minor arc I taken. Okay. Now, we taken minor arc at the center means that is angle x. Okay. That is double, means 2 times what? 2 times the angle subtended by it, means minor arc at any point on the remaining part of the circle. If this is the minor arc, then what is the remaining part of the circle? That is this one, upper one. Okay. So, in that if you take a point, one point, any point P where you have to take on the remaining part of the circle. That is, if you consider minor arc, then the remaining part of the circle is a major arc side. Okay. On that side you have to take one point and join that point P with the ends of this minor arc. Okay. So, then one angle is formed, angle Y, and that angle Y is what? That is the angle subtended by the minor arc AB at any point P on the remaining part of the circle. Okay. So, according to this theorem, what we can write? X equal to 2 times this. Okay. What is x? X is the angle subtended by an arc at the center of the circle, that is x, and that is double, means 2 times the angle subtended by it, means arc at any point we taken point P on the remaining part. Now, if you taken minor arc, then remaining part will be major arc. Okay. Major arc of the circle, remaining part of the circle. So, according to this theorem, this is the second angle subtended by arc at any point on the remaining part of the circle, that is the angle Y. So, x is equal to 2 times y. Angle x is what? That is the angle subtended by minor arc at the center, and that is double, means 2 times the angle subtended by it, means minor arc at any point P on the remaining part of the circle, means x equal to 2 times y. Always you keep in mind that angle subtended by an arc at the center is 2 times the angle subtended by that at any point on the remaining part of the circle. Okay. Angle at the center is 2 times the angle at the circumference of the circle, like that you keep in mind. Okay. Angle at the center, that is 2 times the angle subtended at any point on the remaining part of the circle, that I will take as a circumference of the circle. Okay. So, this is for a minor arc, and same type you can say for a major arc also. Suppose you have a major arc. So, now I will take a major arc. Now, this is the lower side, you have a minor arc. Now, I will take a major arc. This is the major arc upper side, and the center of the circle we take as O, and if you join the end points of this major arc with the center of the circle, then the angle formed major arc side. This is a major arc side, and I will take that as a angle x, and you take any point P on the remaining part of the circle. If you consider major arc, then the remaining part of the circle is a minor arc side. On that side if you take one point, any point P, then you join that P with the A and B like this. So then this angle, I will take that as a angle Y. Now according to this theorem, you can write the angle subtended by the major arc at the center, that is double, means 2 times the angle subtended by it at any point P on the remaining part of the circle, that is 2y. Okay, x equal to 2y. What is x here? X is a reflex angle AOB, that is 2 times the angle subtended by the major arc at any point P on the remaining part of the circle. So always a center angle, that is 2 times the angle at the circumference of the circle, that you keep in mind. Okay, thank you. Next, in the figure, A, B and C are 3 points on the circle with the center O, such that angle BOC, that is 30 degree, and angle AOB, that is 60 degree. If D is a point on the circle other than the arc ABC, side, one point D is taken, you have to find what is angle ADC. Okay, so now here you can see ABC, that is the minor arc, and what is angle AOC? Angle AOC, that is the angle made by the minor arc ABC. Okay, so angle AOC, that is the angle made by the minor arc ABC. Okay, at the center of the circle, that is according to theorem 8, what it says, the angle subtended by an arc at the center, that is angle AOC, that is double means 2 times the angle subtended by that arc at any point on the remaining part of the circle. So according to that, we can write 2 times this is what angle ADC, that is the angle made by same arc at any point D on the remaining part of the circle, right. So 2 times angle ADC we can write, and this is by using theorem 8. Okay, angle subtended by the minor arc at the center, that is angle AOC, that is 2 times the angle subtended by the minor arc at point D on the remaining part of the circle. Okay, so by that theorem we how to write like this first. But what is angle AOC? In that you have 2 angles. Okay, sum of that 2 angles is what? Angle AOC, 60 degree plus 30 degree, that is how much? That is 90 degree. Okay, 60 degree plus 30 degree, that together gives you angle AOC, and that is equal to 2 times angle ADC. And 60 plus 30, that is 90 degree, that is equal to 2 times angle ADC. Now we have to find what is angle ADC. So what you have to do is you keep only angle ADC on the right side, and into 2 you take another side as by 2. Okay, so 90 degree dividing by 2, and that simplifies to 45 degree. 90 by 2 means half of 90, that is 45 degree. So angle ADC is how much? That is 45 degree. Okay, problem is in a figure angle PQR, that is this angle, that is 100 degree, where P, Q and R are points on the circle with the center O. Find angle OPR, that is this angle you have to find. Okay, OPR, this angle you have to find. And here also you have to apply theorem number 8, and this is which arc? This is a major arc, right, major arc, and the angle subtended by this major arc at the center of the circle is this angle, that is a reflex angle POR. So that reflex angle POR, that is equal to what we can write according to theorem number 8. This is the angle subtended by the major arc at the center, that is reflex angle POR, that is 2 times the angle subtended by this major arc at any point Q on the remaining part of the circle, that is 2 times angle PQR. But we are given angle PQR, that is how much? That is 100 degree. So that is equal to 2 into 100 degree, that gives you 200 degree. Okay, so what is this? This is a reflex angle POR. So we got a reflex angle POR, that is how much? That is 200 degree. Now using this reflex angle POR, we can get what is a reflex angle POR. Always to get a reflex angle of some angle in general, I will take as angle A. You have to use this formula. How to get a reflex angle of angle A? Just you have to subtract angle A from 360 degree. Okay. So now we have this one, reflex angle of what? Reflex angle of a POR. To get that, what usually we do? We have to subtract angle POR from 360 degree. Okay, according to this general formula. This is the general formula to find a reflex angle of angle A. Okay, you have to subtract angle A from 360 degree. Okay, same formula you have to use now. Reflex angle POR, that is equal to 360 minus this angle POR. Okay, so here which one we know that you replace? We know now reflex angle POR, that is how much? That is the 200 degree. So here 200 degree, that is equal to 360 degree minus angle POR. Just to take on this angle this side and 200 that side. So that gives you 360 degree minus 200 degree. Okay, 200 degree. That gives you what? That gives you angle POR. POR is taken to the left. Okay, and that gives you 0 minus 0 0, 6 minus 0, that is 6, 3 minus 2, that is 1, 160 degree. Okay. So what is the 160 degree? That is this side angle, that is 160 degree now. Now we have to find this angle, that is angle OPR, and can you see OP and OR are what for a circle? They are radii for a circle. Okay, so these two are equal in length. For a given circle, radii are equal. Okay, so OR is equal to OP. Now you have a triangle like this. This is a PR, and like this you have triangle. This is O. OP and OR, they are equal. Why? Because they are a radii of the circle. And you know that if two sides are equal in a triangle, then the angles opposite to them are equal. I taken this angle as these angles opposite to these equal sides as x. Okay, so these angles are equal. Okay, so we take these unknown angles as x, same x. Okay, why they are same? Because these two sides are equal, so angles opposite to them are equal. So we taken these two angles as equal. Okay, so now in these in this triangle, what you can write? See, you know, sum of angles in any triangle is how much degree? Is 180 degree. So by using that, what we can write for this triangle OPR, angle x plus angle x plus 160 degree, that is equal to sum of three angles of a triangle is 180 degree. X plus x, that is 2x plus 160 degree, that is equal to 180 degree. So from that you will get a 2x equal to 180 degree minus 160, another side as minus 160 degree. 180 minus 160, that gives you how much? 20 degree. So 2x equal to 20 degree means x is equal to 20 dividing by into 2, another side as by 2. 2 ones are 2 10 times. So x is equal to 10 degree. What is x angle? Angle x is nothing but angle OPR. Okay, so that is equal to, here only you can write, that is equal to angle OPR. Okay, so we got which one? Angle OPR, which is asked in the question. First you have to use theorem 8. Using that you will get this angle POR, that is reflex angle POR 200 you will get because angle subtended by this major arc at the center, that is 2 times the angle subtended by the major arc at any point on the remaining part of the circle. Using that we got a reflex angle POR. After that, using reflex angle POR, we got angle POR, it is 160 degree that we wrote in the figure. And if you observe the figure, you can see that OP and OR, they are radii of the circle and they are equal, but they are sides of this triangle OPR. Okay, if two sides are equal, then the angles opposite to them are equal. So by that we taken these both angles as a same x. Okay. Next we use the interior angle theorem of a triangle. Sum of angles in any triangle is 180 degree. Using that we got like this, x plus 160 is equal to 180, adding x plus x 2x, 160 we taken to the right side as minus 160, that gives you 20 degree, and that is 2x. From that we got x equal to 20 by 2, that is 10, and that is what x, that is angle OPR as well as angle ORP. Okay, but here asked angle OPR, so that is equal to 10 degree. Okay, thank you. Next angles in the semicircle is 90 degree. That is when you have semicircle, suppose you draw a circle and if you draw diameter of that circle, then on both side of that diameter you have semicircle. Okay, part of the circle on both side of that diameter is a semicircle. Suppose AB is a diameter, then on both side of that diameter you have semicircle. Angle in the semicircle is 90 degree. Angles always if you take any angle in the semicircle, that always measures 90 degree. You can do that activity. Okay, draw one circle and draw one diameter and take any point on the semicircle, either here or anywhere on the semicircle. Okay. So then you join that P with the A and B and measure this angle, that measures 90 degree. And same type here also, if you take a point Q on another semicircle, then if you join QB and QA, then this angle also measures 90 degree. Always any angle in the semicircle that measures how much degree, that measure 90 degree. Okay, so that is about this note, angle in the semicircle is 90 degree. And next you have a theorem, angles in the same segment are equal. Okay, when you have segment, if you draw circle and if you draw one chord in that circle, I will take that chord as AB. Okay, then both side of AB you have segments. Okay, this region is called segment and this region is also called a segment. This is minor, this is a major segment. Angles in the same segment are equal. Suppose I take a point P and point Q. If you join P with the A and B and Q with the A and B, then you have two angles in the same segment, in the major segment, angle P and angle Q. That are two angles we taken in the same segment, in the major segment. These two angles are equal. Okay, angle P is equal to angle Q. Same type, if you take 2 points C and D on the minor arc side, and if you join a C with the A and B and D also with A and B like this, then C and D, that two are angles in the same segment, minor segment. Okay, they are equal. Angle C is equal to angle D. Yeah, you can do one activity, draw one circle and draw one chord and take 2 points, any 2 points, either in the major segment or in the minor segment. Okay, you take 2 points on the major arc and join that 2 points with the A and B, then you will get angle Q and angle P. Okay, and measure that two angles, they measure same. So angle P is equal to angle Q, angle C is equal to angle D. What they are? They are the angles in the same segment. P and Q are the angles in the major segment, C and D are the angles in the minor segment, they are equal. Okay, so that is about theorem number 9. Then cyclic quadrilateral. Cyclic quadrilateral means that is the quadrilateral whose all 4 vertices are on the circle. Okay, suppose see here, you suppose you draw one circle and suppose you draw a circle and if you take 4 points, non-collinear points A, B, C, D, and if you join A, B, B, C, C, D and D, A, DA, Then you can see one quadrilateral and whose vertices are A, B, C, D. All these are 4 vertices. They lie on the circle. Such type of quadrilateral is called a cyclic quadrilateral. Okay, so always vertices of a cyclic quadrilateral are always on the circle. Okay, so that is the cyclic quadrilateral. Next you have 2 theorems related to cyclic quadrilateral. That is the sum of either means both the pair of opposite angles of a cyclic quadrilateral is how much degree? 180 degree. That is, if I take angle A as a x, this as y, this as a z, this as a w, opposite angles pair which are opposite angles x and z, they are opposite angles and w and y, they are opposite angles pair. Okay, x with the z, y with the w. Okay, these are 2 pairs of opposite angles in this quadrilateral. What that theorem says, the sum of either pair of, either means both pair of opposite angles is how much? 180 degree. That is only in a cyclic quadrilateral. Okay, sum of opposite angles is how much degree? Is 180 degree. That is only in a cyclic quadrilateral. That is about theorem number 11. And you can say converse also. Suppose any one pair of opposite angles are supplementary. That is, if sum of a pair of opposite angles is 180 degree, then you can say that quadrilateral is a cyclic quadrilateral. Okay, so this theorem 12 that says that if a sum of a pair of opposite angles is 180 degree, that is, if one pair of opposite angles sum is 180 degree, then we can say that quadrilateral is a cyclic quadrilateral. Okay, that is theorem 12. Thank you. Next is in a figure angle ABC angle, that is 69 degree, and angle ACB, that is 31 degree. You have to find angle BDC. Okay, that is this angle you have to find. But directly we can't get this angle D, we can get what is angle A. Okay, it is easy to get angle A. You just observe this much in the main figure, part of the figure, ABC triangle you can see here. Okay, in that angle B is 69 degree and angle C is 31 degree. You know how to get the third angle. If 2 angles are given to you, then easily you can get the third angle. Subtract the sum of these 2 angles. What is the sum of these 2 angles? 69 plus 31 degree. That is how much? That is 100 degree. Okay, so 100 degree, that is the sum of these 2 angles, that you have to subtract from 180 degree. Okay, how much that gives? That gives you 80 degree. Okay, so angle A, that is equal to how much? That is equal to 80 degree. That is angle BAC. Okay, so if angle BAC is 80 degree, then angle BDC is also 80 degree. Why? Because can you see here? Angle A and angle D are the angles in the same segment. Here you have chord BC and above that you have major segment, and we know that angles in the same segment are equal. So angle A is equal to angle D, but angle A that we know that is 80 degree. So angle D is also equal to 80 degree. Okay, first you have to get angle D by using interior angle theorem. Okay, so by interior angle theorem I can get what is angle D, that is 80 degree, and that is equal to angle A. Why? Because we know that angles in the same segment are equal. So angle A is equal to angle D. By that we get angle D, that is angle BDC. Okay, you have to write angle full name, angle BDC. Okay, detailed steps given in the notes that you have to write for the exam, not like this. Okay, and next problem is in a figure A, B, C and D are 4 points on the circle AC and BD. AC and BD intersect at a point E. You can see that AC and BD, they are intersecting at a point E such that angle BEC, that is a 130 degree, and angle ECD, this angle ECD, that is 20 degree. Find angle BAC. Okay, this angle you have to find. Here also directly you can't get a angle BAC, but you can get what is angle D. Okay, once you get angle D, using the concept that angles in the same segment are equal, we can equate angle A and angle D. Okay, so if you get angle D, then angle A is also equal to the same, that is angle A is equal to angle D. How much angle D measures the same angle A also. Okay, but how to get angle D? To get that angle D, you just see BD, that is a straight line, and on one side of this total angle, on one side of that straight line must be equal to 180 degree. Can you see like this in the main figure? I'll highlight only part of the figure. Like this you have BD, and here you have this one AC, and this angle you are given, that is 130 degree. Okay, this BD, and this is a line AC standing on this line. Okay, and this angle we know 130 degree. So how much left in 180 minus 130, that gives you how much 50 degree. So this angle we can write 50 degree. How we wrote this? Because we know that total angle on one side of a straight line is 180 degree, but in 180 degree 130 is here. So how much left? To get that, you just subtract 130 from 180, that gives how much 50 degree. So that is the other side angle. Okay, so by that we got this angle 50 degree. So now you see only part of the figure, that is you have to observe now EDC triangle. Okay, like this you have EDC triangle. In that we know now this angle 50 degree, and this angle we are given in the question, that is 20 degree. So sum of these two angles, that is 70 degree, and third angle is unknown. That to get that unknown angle, just subtract the sum of these two angles from 180 degree. That gives you how much degree? 110 degree, right? So this angle D, that is how much? That is 110 degree. So if this is a 110 degree, we know that angles in the same segment are equal. So angle A is equal to angle D. Why? Because these two angles are angles in the same segment, in the minor segment. Okay, angle A and angle D, that are the angles in the minor segment, so they are equal. Just now we got angle D, that is the 110 degree. So angle A is also 110 degree. Okay, detailed answer is given in the notes that you have to write. Okay, here I explained just how to get that angle. Okay, thank you. Next problem is ABCD is a cyclic quadrilateral whose diagonals intersect at a point E. If angle DBC is a 70 degree, angle BAC is 30 degree, find angle BCD. Further, if AB is equal to BC, find angle ECD. Okay, so what you have to do is you have to draw one cyclic quadrilateral ABCD. That is, first you draw one circle. Okay, and take 4 points on that circle, so that you can draw one quadrilateral. Okay, I will take A, B, C and 4 points I taken on the circle. Now I will join DA, BC and AB, BC, CD and DA you have to join. Okay, so then you will get a cyclic quadrilateral, and the diagonals of that you have to draw, and they are intersecting at a point, and that point you have to name as point E. Okay, this point you have to name as point E. And what you are given now? See which angles we are given, that we write in the figure. Okay, angle DBC, that is this angle DBC, that you are given, that is 70 degree. So this angle is how much? That is 70 degree. Angle BAC, that is this angle BAC, that is 30 degree, and you are asked to find angle BCD. Okay, you have to find what is the angle BCD. This angle, full angle BCD you have to find, And next further, if AB is equal to BC, if AB is equal to BC, then you are asked to find angle ECD. ECD means this angle you have to find, okay, ECD, this angle. How to get this angle? See here you have to observe now only part of the figure, okay. You have circle like this, and this is a chord DC, and here you have what angle DAC, and this angle is a DBC, okay. And DBC angle we know that is how much degree, 70 degree, and we know that angles in the same segment are equal. Here you have major segment, angles in the same segment are equal, so we can write this angle is a 70 degree, that is angle DAC. So I will write that here, actually that is not given, using the concept that angles in the same segment are equal. You can see here, okay, these are the angles in the same segment. So these two angles are equal, but this angle is given to you, that is 70 degree. So this angle is also 70 degree. So here you can see now angle DAB. DAB is how much? Full angle DAB, that is angle DAB, that is equal to total of these 30 plus 70, that is 100 degree, okay. And we know that in a cyclic quadrilateral opposite angles are supplementary, that is sum of opposite angles is 180 degree. So angle A, that is DAB angle, plus this angle, that is BCD angle, sum of that is equal to how much? Sum of that is equal to 180 degree. But DAB angle, that is how much? That is 100 degree, plus angle BCD, that is equal to 180 degree. So from this you will get angle BCD is equal to how much? 180 degree, 100 another side as minus 100, okay. 180 minus 100, that is how much? That is 80 degree. So this is what? This is angle BCD. Where is angle BCD? That is full angle. This full angle is how much? That is 80 degree. I will write here. This is 80 degree now. Now what we have to find? We have to find what is this angle. That is the DC, which angle? Sorry, ECD angle you have to find. How to find angle ECD? See here, to find angle ECD, you have to use that AB is equal to BC. Now you observe this triangle, okay, ABC triangle. In that triangle, these two sides are equal. If these two sides are equal, then angles opposite to them are equal. So here you have 30 degree, and this is also 30 degree. Why? Because these are the angles opposite to equal sides, okay. These are equal sides, so angles opposite to them are equal. 30, this angle is given to you, that is 30 degree, so this angle is also 30 degree. But what we know, this full angle is 80 degree. From 80 degree, if you subtract this 30 degree, if you subtract this 30 degree, then what you will get? You will get this angle, that is angle ECD, okay. So angle ECD, to get that, what you have to do? You have to subtract 30 from total 80 degree, okay. Total angle C is 80 degree, and in that this much part of angle C, that is 30 degree. If you delete that, then you will get angle ECD, and that is how much? That is equal to 50 degree, okay. So angle ECD is 50 degree, okay. Detailed answer is given in the notes. That answer you have to write for the exam, not like this, okay.